The combined gas law is just a combination of Boyle's, Charles's, and Gay-Lussac's law. So if we look at Boyle's law, P1 times V1 equals P2 times V2. We look at Charles's law, V1 over T1 equals V2 over T2. And Gay-Lussac's, P1 over T1 equals P2 over T2. The combined gas law is just going to make a composition of all of these. So we end up getting P1 V1 over T1 equals P2 V2 over T2. Now, I always like to add in the amount of gas as well. So to the bottom, we can actually add in N1 and N2, N being the moles of gas that we're talking about in a given scenario. So P1 V1 over N1 T1 equals P2 V2 over N2 T2. Now, the cool thing about this is if any of these is held constant, we can actually figure out Boyle's, Charles's, or Gay-Lussac's law. So let's just say the amount of gas and temperature was held constant. Well, if that's the case, then we can just scratch out the bottom here because N2 or N1 are the moles of gas and the temperature are being held constant, and take a look what we have. We have Boyle's law. We can do the same thing for the other gas laws as well. So if we had volume being held constant and the amount of gas being held constant, we would end up getting Gay-Lussac's law. With Charles's law, we'll just be holding pressure and the amount of gas constant, and we would end up getting V1 over T1 equals V2 over T2. So here's a combined gas law problem. The volume of a gas is 27.5 milliliters at 22.0 degrees Celsius and 0.974 atms of pressure. What will the volume be at 15 degrees Celsius and 0.993 atms? So first thing I want to do is write out all of my variables. So I have V1, P1, T1, and my final volume, V2, my final pressure, P2, and my final temperature, T2. So V1 is equal to 27.5 milliliters. P1 is equal to 0.974 atms. T1 is going to be 22.0 degrees Celsius. V2 is what we're solving for. P2 will be 0.993 atms of pressure, and T2 will be 15 degrees Celsius. So, first thing I want to remember to do is convert my temperature to Kelvin. So I'm going to add 273 to each. So my initial temperature is 295 Kelvin, and my final temperature is 288 Kelvin. I'm going to minimize the problem here, and we can plug in our variables and calculate. My equation is P1 times V1 over T1 equals P2 times V2 over T2. P1 is 0.974 atm times V1, 27.5 milliliters, divided by 295 Kelvin. All that is going to be equal to P2, 0.993 atm times my unknown variable V2 divided by 288 Kelvin. Now that I made the problem a bit smaller, now we can solve for our unknown variable. So I'm going to multiply by the reciprocal here to get V2 by itself. So reciprocal just simply is 288 Kelvin over top of 0.993 ATMs. I'm going to multiply both sides by the reciprocal. So 288 Kelvin over 0.993 ATMs. Now notice my Kelvin cancels out, my ATMs also cancel out on both sides. So I'm left with a unit of milliliters. So when I type this into my calculator, I'm going to take my 288, multiply it by 0.974, multiply it by 27.5, divide that by 0.993, and divide that by 295. I get a final answer of 26.3 milliliters.